Let's do this problem right here. It's asking to sketch, uh, do the curve sketching for this equation. So let's see how we can do this. So first of all, we have to state the domain. So if you see, this one can be any real number. In this case, x can be any real number. So domain is going to be, so a domain is going to be x can be any real number. So this is my domain, and then we have to find intercepts. So first let's see how we can find the y-intercept. To find the y-intercept, I have to set x is equal to 0. So if you see, if I set x is equal to 0, 0 here is going to be y is equal to 0. So that's my y-intercept. Also the point is going to be like when you so therefore x is equal to 0, y is equal to 0, 0, 0 is the point. Then I have to find the x-intercept. X-intercept, I have to set the y is equal to 0. So if I set y is equal to 0, let's see what happens. So x plus 3x 3x 2 by 3 is going to be equal to 0. And then I can take the x2 by 3 common. So if I take x2 by 3 common, I will get 1 here. No, this is 1. So this is going to be, so if I take this common, this is going to be x 1 by 3. 1 by 3 here is going to be plus 3, therefore this equal to 0. Then we can say x is equal to 0 also, and x 1 over 3 plus 3 is equal to 0. If I solve for this one, I will get x 1 over 3 is equal to minus 3, and if I cube both sides, this will cancel, and it's going to become x, and if I cube this side, it's going to be minus 27. So these are my x-intercepts. So this is going to be 0, 0. So my x-intercept is 0, 0, and 0, 27, minus 27, 0. So these are my two x-intercepts. Now I have to find whether it is symmetrical or not. So to find the symmetrical, I had to set this one into f of negative x and see whether it is symmetrical. So first of all, if I set f of negative x, what will I get is negative x plus 3 negative x power 2 by 3. So if you see, this going to become this will be remaining the same, and in this case, if you square the negative x, that's going to be positive x. So it's going to be plus 3x 2 by 3. So to check whether it is a even symmetry, we have to know that if this is f of x is equal to f of minus x. So if both of them are equal, then it's even symmetry. But in this case, this is not equal to the original function. So this is not even symmetry. So to check whether it is odd symmetry, this f of x is equal to f of minus x is equal to minus f of x. So that's not true either, because f of minus x mean minus x, and this comes out to be this one, and minus f of x means the whole thing should be negative. So in this case, this should be, if this is negative, that's true, but in this case this is positive, therefore this is not true either. Therefore this is not symmetric. And let's move to the next one. So D, asymptotes. So to check the asymptotes, to check whether with the vertical asymptote, I have to set the denominator equal to 0. Since this one has no denominator, there's no vertical asymptote. Then to find the horizontal asymptote, I had to find the y value when x is approaching infinity. So when x approaches infinity, by looking this equation, you can say if you apply infinity plus infinity, that's going to be infinity. If you apply negative infinity, negative infinity plus negative infinity, that's also going to be a negative infinity, right? So therefore there's nothing, there's no horizontal asymptote too, because that doesn't give any value, like, so that doesn't give any value, therefore no horizontal asymptote. Then intervals of increase and decrease. To find this one, I have to take the first derivative. So first derivative, this one is going to be, so let's see, f of f prime x is equal to the derivative of this one is going to be 1. Then derivative of this one is going to be 2 over 3 minus 3 by 3. It's going to be minus 1 over 3. Therefore, it's going to be plus 3 3 over minus 1 over 3 means it comes to the bottom and it's x power 1 over 3. So this is going to be my derivative of this function. Then from the derivative I can check whether it's increasing. So now I have to find the critical points to check the increasing and decreasing. So in this case this is two different. So to make it simple, I have to add them together. So to do that I have to multiply this one by x to x by x power 1 by 3. So if I multiply it, this will become x power 1 by 3 plus 3 over x power 1 by 3. From this one I can find the critical numbers. To find the critical numbers we have to have two set of conditions. First of all we have to find the value that gives this equation undefined. So in this case usually the bottom x we equalize x equal to 0. So in this case if it's directly comes out to be 0, because if this is equal to 0 then this whole equation become undefined. Therefore x is equal to 0 is a critical number. So this is one of the critical number, and to find the other critical number we have to make the whole equation equal to 0. So if I equalize to 0 we don't have to worry about the denominator, because if I bring the denominator to the other side it will multiply by 0 and it will become 0. So we don't have to worry about that. But let's consider the numerator. So if I set the numerator into 0, x plus 3 is equal to 0, and this is going to be x power 1 by 3 is equal to negative 3 and okay, wait a minute. So this is actually this is 2, because the derivative of this one, if I take the derivative I multiply this one by this one, 3 cancel and 2 is remaining, and 2x power minus 1 over 3, that's why this is 2. So that's a mistake right here. So this is 2, then this is equal to 2, 2. Therefore now I have to cube root both sides, so it's going to be x is equal to minus 8. So this is my critical point, another critical point. So now we have to check the values between the critical points, whether it is positive or negative. So let's take the critical points. So this is negative 8, and this is one of the other critical point is 0. So 0 and 8 are the critical numbers. So I square this one to make it clear. So 0 and 8 are critical numbers. So let's check the values above the critical number. So if I plug negative 9, let's say negative 27 is easy, because that can be easily cube root, right? So in this case if I cube root negative 27, it's going to be negative 9 here. So negative 9, and on the top, let's see, negative cube root of 27 is negative 3. Negative 3, 2 divided by negative 3 is a negative value, and 1 and is it 2 divided by negative 3, is it less than, yeah, it's less than 1. 1 minus this one is going to be a positive number, therefore this is going to be a positive value. So that means this is increasing, and then we have to pick up a value that is within this interval. So let's take the negative 1, that's easy. So if I take the negative 1 for this one, power of this one gives us negative 1, and then divided by 2 divided by negative 1 is going to be negative 2, so therefore it's going to be a negative value. So it means this is decreasing in this interval. And then I have to pick up a value above 0, so let's pick up 1, that's easy. So the 1 plus 2 over 1 is going to be 3, that's positive numbers, then this is a positive increasing. So that's what we need to know. And from this one also the next one, so we found the intervals increase and decrease, no local minimum and local maximum. So in this case you see negative, so we don't have horizontal asymptote, vertical asymptote, so this is going to be continuous, therefore we can select this one. So in this case if you select the values negative 8 and before negative and after negative 8, it's increasing and decreasing. It means the value of negative 1 is negative 8 is local maximum. increasing and decreasing mean the graph is going something like this, right? So it means it's a local maximum, and then from -8 to 0 it's decreasing, then after 0 it's increasing. It means it's going down and going up, then it means local minimum. So local maximum, max is -8, local min is negative, local minimum is 0. So these are the 2 points we need to know. And then if you go for the F part, that's what we done here. So F part is done, and let's go to the G part. G part is asking find concavity and the inflection points. To find that, I have to take the second derivative. So in this case, it's easy to take the second derivative of this one. This one is very easy because in this case I have to use quotient rule and stuff like that. So to avoid that, I can take this one and find the second derivative. So if I take this one, so let's mention here where f prime x is equal to 1 plus 2 over x 1 3, and if I take the second derivative, this one will become 0 plus this is basically I can write it as 2x minus 1 over 3 derivative. So if I find the derivative for this one is multiplied by this one, so it's going to be negative 2 by 3, then minus 1, so it's going to be minus 3 by 3, it's going to be minus 4 by 3, so it's going to be x minus 4 by 3. Therefore we can write this one as minus 2 by 3 x power 4 by 3. So this is how the value comes out to be. Then in this case the critical point is going to be 0, critical number, because 0 makes this one undefined, because so that's why it's 0. Then I can also set the f double prime to 0 to find the other critical numbers, but in this case it does not exist, because if you see in the numerator there's no x values. So it means if you plug 0, or like if you get the 0, if you equalize this one to 0, this one multiply this and this side and becomes 0, and minus 2 is equal to 0. That doesn't mean anything, right? So it means this is the only critical point we have. Therefore we have to check the points below and above this 0, positive or negative, to determine whether it's concave up or down. So let's see the values. First, for example, below 0, I can pick up -1 and apply in this double derivative. So if I apply negative value here, so if you see the x power 4 mean whatever the value, if you pick negative or positive, the value is going to be positive value. So if you divide a negative number by positive, it's still going to be negative, so it's going to be negative here. So it means concave down, CD. Then above 0 is same thing. If you pick something like 1 or 2, whatever it is, it's going to be a positive value, and if you divide this one by negative value divided by positive value, still going to be negative, so it's also concave down. So now we are ready to draw the graph, and we have to know inflection point. Since we don't have horizontal asymptote or vertical asymptote, this is going to be our inflection point. So 0 is our inflection point. Inflection point, and that's all we need to know to draw the graph. So let's do this one. Okay, so first of all, this is all real number, and we have an intercept at y is equal to 0, 0, 0. So this is our intercept right here. Also we have when x is equal to -27, y is equal to 0. So -27 means it's somewhere here. So let's say -27. This is 0. Then so this is from this information. Then this is not symmetrical, so we don't have to worry about it. No vertical asymptote, no horizontal asymptote. And if I move to this one right here, so it is increasing until -8 and decreasing after that. So there's a local maximum at -8, and you can find the y value of this one by plugging this into the original function. So let's do this one. So it's increasing, and this is going to be some point when you apply this one into the original function, and it's going all the way down until 0. So according to this point, so it's going all the way down until 0. Then in 0 it's increasing. So increasing, and also this is concave, so we have to consider this one too. So concave down, so this is concave down, and it's concave down and increasing. So concave down and increasing mean it can't be like this. So this means this is concave up and increasing, right? So it's not possible that way. So in this case, this is concave down and increasing. It means the graph is going to be something like this. So it's going to be a cusp right here. So it's going all the way right like this, and that's how our graph is going to look like. That's how it is, and that's all about it. I hope you guys like this video. See you next time.